Hey guys, in this video we're going to be talking about a concept of trigonometry that refers to addition of ordinates and multiplication of ordinates. Now you're seeing on this graph, this is what's called a virtual oscilloscope. It's used to analyze waveforms and sounds sometimes, and you can see it's going crazy as I'm talking. But what we're going to be looking at is how periodic waves, sine waves, cosine waves, that they're basically distorted, and that can happen from combining different waves together. So instead of looking at a singular wave or a singular periodic function, we're actually going to look at what happens if you combine two functions together through addition and also through multiplication. So what I want you to notice is I'm getting ready to play a sound, and you'll see the oscilloscope as it's recording these sounds. You can see it going crazy, and that's because you have all kinds of different sound waves that are happening in my voice. It's not a pure tone, but if we create a pure tone, you will see it look much more like a sine or cosine wave. So let's try this. And there you go. You see, if I freeze it, you actually start to see that sine or cosine wave. So that's one example. Now, if I do a higher pitched, like maybe I try to whistle, let's see how that looks. Okay, so you see, again, another sine or cosine wave, but this one it looks like it has a higher frequency. You can see that there are more of those waves or more cycles in a given amount of time. So what happens if we combine these two ideas? So I'm going to play the tone and whistle at the same time, and let's look at what that looks like. Here we go. So this is a perfect example. So if you'll look at this, you'll see how you can kind of see the big wave happening, but it's almost like it has smaller waves in the big wave pattern. So we're going to talk about like why that happens, what's causing that to happen and generate that kind of pattern. So let's get over and actually get to where we can see this. So on the screen, I have created two functions, and I've got this pulled off Desmos. The functions that we have here are the normal sine graph, and which is the red graph. So let me make sure I do this correctly, just try to keep things in place. So I'm going to say that the red graph, I'm just going to put it up here to the side, is sine x or sine theta, x just being an input referring to our x-axis here. And then the blue is a cosine graph, but I've given it a higher frequency. So that one is cosine of 4x. So that's why it's occurring with more cycles. So what I want to talk about is, let's suppose for a second that the sine function is my f of x function, and the cosine function, we'll call it our g of x function. Now, the question is, what would happen if I was to combine these functions through addition? So that's going to be f of x combined with g of x. Now, it's going to basically create an output like what you saw a second ago with that oscilloscope. And we'll see this happen here in just a minute. But what I want you to do is kind of get to where we can predict what's going to happen. And the way you do this is really not that difficult. Notice how I'm taking whatever value I have for the f function and whatever value I have for the g function at any given x, and we're going to add those together. So an easy example here would be to look at the f function, which is the red. Let's look at it at the x value of 0. So in this portion. So I would have a red value of 0 and a blue value of 1. So the f function would have a value of 0. The g function would have a value of 1. So if I'm looking at that kind of like a table, just to kind of generate what would happen. So if I'm looking at an x value of 0, and look at what the f of x function is, what the g of x function is, and then what's the sum of those two. And let's just kind of track these for a second. Okay, so if f of x at 0 is 0, g of x is 1, then f plus g would have an output of 1. So that means that my f plus g function, it would be plotted here. Now let's try maybe at this value of, let's try 1 and see what happens. So at a x value of 1, I'm going to have a f function, sorry, f is the red, an f function value of not quite 1. Let's just estimate here. We don't have to be super specific. I'm going to say about 0.8. So 0.8. And a g of x function, which is the blue, of about negative 0.6 maybe. Let's say negative 0.6. So if I add those together, then I'm going to get a positive value of 0.2. So 0.2 here at the 1 value would be, oh, I lost my ability to mark there for a second. So it'll be at about 0.2, so that's going to be somewhere here. So let's try maybe, what about if we come, if this is 1, what if I go to about 0.75? Let's just back it up there and see what happens there, because that's kind of got a good dip there, an extreme, and I'm just curious what's going to happen. So if I go with an x value of a 0.75, which is right in here, the sine function appears to be, if this is 1, maybe about 0.75. And then the g function would be negative 1. Well, that would be about a negative 0.25. Well, a negative 0.25 would be roughly here. Okay, so you can start to see how these things are combining to create this weird wave. Okay, what if we come to an x value of 1.5? The f function, which is the blue, sorry, right here, would be at 1, and the g function is at 1. So that would create an f plus g value of 2, which would be up here. Okay, what about if we come to an x value of 2? And at 2, the f function is about 0.8. The g function, maybe about negative 0.2. So that would create a sum of 0.6, which would be about here. And we'll try, let's see, so there's 2, here's 3. This would be 2.5. And just, let's try maybe, let's go ahead and try that at 3. See what that's looking like. So at 3, I have an x value of maybe 0.2. I have a g value of about 0.8, which would give me a sum of 1. So that's going to be here. Okay, so you can start to see this general pattern if I'm just starting to sketch, so you can see kind of what's happening. Now, this will give you an idea of how these things are structured. So what I want to do, instead of going through this over and over, because you can see this does take a little bit of time, and actually show you what this is going to look like visually on Desmos whenever we add these two together. Now, the benefit when we do this on Desmos is I want to put it in as f of x and g of x like this, and that way I can create a third line where I can actually add those two functions together, and it's actually like a combination of functions. All right, so what I'm going to do, let me pull this over. So you can see this is the exact graph we were just talking about. The red is my sine function, the blue is my cosine of 4x function. So if I do this line here, f of x plus g of x, then watch what happens. So now you can actually start to see that pattern of what we were doing a second ago, of how it's starting to resemble that curve happening. And you can see why it's forming this pattern, because it is the addition of the blue line and the red line getting put together. So what you'll notice is that the graph kind of seems to take on this wave of that sine function, but then within that sine function, it has the components of the blue function. Okay? So that's how you do addition of ordinates. Now, another example that I'm going to throw up here is what would happen if I were to combine these two together. So here we have an example of a sine function being plotted, regular sine function, and then I also have a linear function of 1/4 x plotted. If we actually combine these two functions, let's see how that looks. Then this is what happens. And if I zoom out just so you can see it a little bit more. And now that you understand how these addition of ordinates work, that should make sense. Because let's just take it the point 10 here, so we can see why the black line is my final output. Well, at 10, I have a sine function value of about a negative 0.5. I have a 1/4 x of about 2.5. Well, if you have a negative 0.5 and a positive 2.5, and you combine them together, you're going to end up at about 2, which is about where we're at. You'll see that y value there, 1.955, really close to 2. So that's how this is happening. This is how this addition of ordinates work. Okay? All right, so I'm going to go ahead and stop this video because this video focused on the addition of ordinates. I'm going to create a second video that will look at multiplication of ordinates. So thinking ahead how that's going to work is really similar, just instead of adding the values as we did here, we will simply multiply them. Everything else works the same. So 1 times 1 would have still been 1, not 2. Okay, so second video, we'll look at this, see how this happens, and good luck.